Alright, welcome to this short tutorial video. In this video, we want to discuss what density is and go on to calculate density given different questions. So, what is density of a substance? Well, density of a substance is actually how much matter is packed per unit volume. So by that, simply saying mass per unit volume of a substance. So density is mass per unit volume of a substance. So that's our definition for density. It's actually how much matter is packed in a unit of volume given. So we have two units in which we can measure density in. The first one is grams, centimeter cubed, and kilogram per meter cubed. So these are the two units in which we can measure density in. The first one is grams per cubic centimeters. These are smaller units of density. The other one is kg per meter cubed. This one, bigger units of density. So we need to understand here that when we are determining the density of a substance, we actually use a particular formula. The formula is so our formula is actually density is equals to the mass of that substance divided with the volume for the same substance. So we can have a situation where the mass of the substance we were determining the density for is in grams, and the volume of the substance we are determining the density for is in cubic centimeters. In a situation where you have that, then the units for density will combine to give you grams per centimeter cubed. So these two go together. So the mass has to be in grams, the volume has to be in cubic centimeters in order to record the volume, the density of a substance in grams per cubic centimeters. But there are other situations where the mass of the substance is actually in meters, in kgs, and the volume of the substance is in meter cubed. So kgs meter cubed, like that. So if the mass of the substance is in kgs and the the volume of the same substance is in meter cubed, then the units for density will be kgs per meter cubed. So then the two will combine and have kg per meter cubed. So you need to understand from there onwards that you can only record two units of densities, grams per cubic centimeters, the other one kgs per meter cubed. So in the fact or in the situation where we are doing calculations and in order to use symbol forms, we have a symbol for density which is like that. It's a Greek letter which is known as rho, like that. So it's RHO. It's a letter in the Greek alphabet. It's not a D, it's not a P, like that. So this is a symbol you use in order to denote density. And for mass, you actually write small letter m, and for volume, you simply write small letter v. So this is the symbol methods for the words density, mass, and volume. So in our next part, we will be looking at how to determine density of the substance. Okay, so we have an example here that has to do with calculations of pertaining density. So in our example here, we have for following situation. A measuring cylinder contains 30 centimeter cubed of a liquid and when a stone of mass 92 grams is lowered gently into this measuring cylinder, it sinks to the bottom and the liquid rises to the 70 centimeter cubic mark, the measuring cylinder. So if you can relate with me, this is a displacement method we were discussing earlier on. So in collecting the information in this question, we are going to say that once we pour water into a measuring cylinder and record the volume, that is recorded as volume 1. So in this case, volume 1 is actually 30 cubic meters. So we're going to say our V1 is equals to 30 cubic centimeters. And when the stone is lowered into that measuring cylinder, we are told that the water level rises to a 70 centimeter mark. Therefore, we understood from that point that V2 is when you have the volume of the stone and the volume of the water inside. So V2 is giving us 70 cubic centimeters. So that is what is going on in this question. So we can also relate that we are given a stone and the mass of the stone. So we can say that mass of the stone is actually given to be 92 grams. Therefore, we know that a stone is actually an irregular substance, and we discussed how to determine the volume of an irregular substance by using a displacement method. Then we can conclude by answering question A to say what is the volume of the stone. So the volume of the stone, being a stone, it is an irregularly shaped object. Therefore, we can determine it using the formula we discussed when we were determining volume of the stone. So the volume of the stone will equal to V2 minus V1. Our V2 is 70 and our V1 is 30. If we do our arithmetic, that will give us 40 cubic centimeters. So that's the volume of the stone in our example. So going to question B here, which says calculate the density of the stone. So in order to calculate the density of the stone, we apply our formula, mass over the volume. So the mass of the stone is given as 92 grams. And the volume of the stone, we are from calculating in A, which is equals to 40 cubic centimeters. And if we do our arithmetic, we say 40 into 92, and that will give us 2.3 grams cubic centimeters. So that is the density of the stone, and that is the volume of the stone. So this is example number 2. In this example, we are told to calculate the density of the ball that is in the measuring cylinder. So we can discuss a few things before we go on to calculate the density of the ball. In this scenario, we are given an electronic balance, and there's a measuring cylinder, and then there's water in the measuring cylinder. So an electronic balance is an instrument used to determine the mass. So in this case, we are determining the mass of water and the mass of the measuring cylinder. So the 72.0 grams is actually telling us that the mass of the water plus the measuring cylinder itself is equivalent to 72.0 grams. Now, what is the volume of the water inside the measuring cylinder? Here we can relate that this measuring cylinder has graduations in milliliters. So we have 50 milliliters and 100 milliliters. So in order to determine one graduation there, we need to find out. So if this is 50 and this is 100, then if this will be 60, 70, 80, 90, then 100. Therefore, one graduation is 10 milliliters. So in order to determine the volume of the water in the measuring cylinder, we simply say 10, 20, 30, 40 milliliters. So this volume here is 40 milliliters. So we've now made it simple for us. The 72.0 grams is the mass of the water and the measuring cylinder itself, and the volume in the measuring cylinder is 40 milliliters. So if we go to the next diagram here, we are showing where we place our bowl now in this measuring cylinder, and we have a value changing here to 105.0 grams. So then in this case, how can we interpret this? The 105.0 grams is the mass of three things: the mass of the cylinder plus the mass of the water plus the mass of the bowl inside will give us this value, which is 105.0 grams. So if we can also note, the volume inside the measuring cylinder actually also changed. Why? Because there was a ball that was placed in, the volume increased. So we can also now determine the volume here. So if this is 50, this is 60, 70, then we have 80. So the volume here is 80 milliliters. Now, in order for us to determine the density of the ball inside the measuring cylinder, we apply a formula. The formula is density will equal to mass over the volume. So we need to know the mass of the stone, and then we need to know the volume of the stone. So in order to determine the mass of the stone, I think we can subtract two values here. So we subtract 72 from 105, because in this scenario we are talking about mass of water plus the measuring cylinder. So added together we get the mass of water and measuring cylinder to equal to 72.0 grams. But here we have mass of water plus measuring cylinder plus the bowl, and this will give us the mass, which is 105.0 grams. So these are the two values. So in order for us to get the mass of the bowl, we simply subtract 72 from 105. We'll get the mass of the bowl. So that will give us 105 minus 72, and this will give us 33 grams. Okay, so that's the mass of the ball in the measuring cylinder. So now how can we determine the volume? Well, the volume in this case, we use displacement method. Before the ball was lowered gently into the measuring cylinder, this was the volume, and this is the same as our V1. And after the ball was lowered into this measuring cylinder, the water level rises, and this gives us volume 2. So subtracting the two will get the volume of the ball. In order to now determine the density of the ball, we have the mass of the ball, 33 grams, and the volume of this ball, which is 40 centimeter cubed. Then we can put our formula for density, where we say density is equal to mass over volume. The mass of the ball is 33 grams, and the volume of the ball is 40 cubic centimeters. Now, in order to calculate density, we just say 14 to 33 will give us a value of 0.825 grams cubic centimeters. So that is how we determine the density of a ball in this example. Hopefully you are now able to determine, or rather define, the term density and calculate given a question. And in the notes below you will find more information on how to go about this topic, density, as well as some examples as well as exercises. See you in the next video.